Hello, this is Teacher Francis Omai. Welcome to my YouTube channel. In our today's video, we're gonna look at reactivity of atoms. And when we talk of reactivity of atoms, we normally say for an atom to react, for it to react, a reaction will involve gaining or losing of electrons. And when we do that, this is to obtain stability. In other words, we do say that stability occurs when an atom has obtained its octet state. Now, when we talk of octet state, it simply means for the first five, their octet state is 2, because it simply means it either gains, for the first 2 they will gain 2, the first one, only hydrogen, will gain to obtain 2 as its octet state. For lithium, beryllium and boron, they will only lose, because they are metals, they will only lose to obtain 2 as its octet state. For the others, the rest has an octet state of 8. 8 means octa. Octa means 8, and when we talk of octet, it simply means 8. Now, for metals, we do say that metals lose electrons. To obtain that which we are calling octet state. And in this case, we do say that metals are form positively charged ions, and these positively charged ions, we call them cations. Cations are positively charged ions. Now, when we talk of non-metals, for non-metals, we do say that these ones gain electrons, and they form negatively charged ions, and these ions we usually call them anions in some other terms, depending on where you studied in your childhood. Now, the non-metals will gain to form their octet states, and that means if we talk of metals, now the first three groups, this one are said to be metals, and then from 3 now to 8, to the 8th group, this one are non-metals, and then from 3 to 7, not 3, sorry, this one is 4. Now from 4 to 7, that means group 4, group 5, group 6, and group 7, they are non-metals, as we've said, but now this one will gain. For the metals here, they will lose. Now group 8, this one has octet state. They have octet state. They have already obtained that octet state that we are talking about, and that means they are unreactive. Now, we can look at shortly how we represent now these ones. Now we have, let's say, a metal like lithium. Lithium has maybe you can represent it as lithium, which is 2 1. It is 2 1, and that means when we draw it, it will be lithium, and then lithium is, this one is 2 and then 1. Now after the reaction, we have, this one is atom, and then here we have ion. In our case, lithium will be cation, and now for lithium, it has to lose this one to obtain the octet state. It is easier to lose 1 than to gain 7, and therefore, because lithium is in group 1, lithium, if we can check on where we did that, lithium is in group 1. This one is group 1, and in group 1 they lose only 1 electron to obtain their octet state. In that case, we have its ion as now it will be having 2, and because it will be having 2, that means it has simply lost 1 electron, and if it has lost 1 electron, it is represented as lithium positive. This one is positive, and it means if this is lithium positive, don't write positive here, it will be the way it was, 2 electrons, but because it has already gained, it has already lost 1 electron, we represent it as positive. That is how we now write the lithium. If we check for another metal like, let's say, chlorine, chlorine has 2 8 7, and that means it only need 1 to obtain its octet state. Therefore, if we draw for chlorine, chlorine will be having the first one with 2, the second one with 8, and then the third one here, the third here we will be having, this one is 2 8, and then the third one has 7, so we have 1 2 3 4 5 6 and then 7. Now when it has already gained, now this one needs to gain 1 electron to obtain its octet state, because gaining 1 is better than losing 7. Now it is easier, and therefore we will have that chlorine having 1 2, and then it will be 1 2 3 4 5 6 7 8, and the last one will also have 8, because now it has gained 1 to obtain its octet state. 1 2 3 4 5 6 7. Now because we had 7, it gained 1. In this case, we will mix to show that it has gained. The dot one is an electron that has been gained. Now when it has gained, we've said for non-metals they gain electrons, and when they gain, they form negatively charged ions. Now the overall charge will be -1 because it has gained 1 electron, and that means the ion will be chlorine negative. You can just pause for a moment and try others out. When an electron, when an atom gains, an ion formed is negative. When it loses, the one that is formed is positive. Now, for all metals, they lose electrons, but for hydrogen, it's a special case because we say that hydrogen can either gain or lose. Therefore, it can be grouped as group 1 or group 7. Group 1, losing 1 electron to form a stable ion. Group 7, gaining 1 electron to form a stable ion. You can just pause for a moment and try this one as an exercise for today. Try that one of magnesium with 12. You can also try potassium with 19. Also try out oxygen with atomic number 8. This one is atomic number number. Now, as I conclude, there are two terms that I want us now to know about them. We have something called electron affinity. Now, we will talk of gaining and losing of electrons. Now, for electron affinity, it is that energy. We do say that it is minimum energy required for an atom to gain or maybe to attract one electron in its outermost energy level. Now, if we talk of chlorine here, chlorine required to gain 1. Now, that energy that is required to gain this 1 electron is what we are calling electron affinity. And then we have something else called ionization energy. And in this case, we do say that ionization energy is the minimum energy required to lose or to remove 1 electron in an atom's outermost energy. Now, this one will be called ionization energy, and we do say that the first ionization energy is the energy required to lose first electron. Now, losing of electrons does not occur concurrently, but rather it occurs sequentially, and that means it will be having the first electron lost, and then followed by the second electron lost, and if it has the third one, there will be third electron loss. And for this one, second energy level, this one is for the second electron. Now, the energy required to lose the first one is less than that which is required to lose the second one. And for that case, the first ionization energy is always smaller than the second ionization energy. Yeah, I think that's all for today. Remember to subscribe and share widely. You can also comment. In the next video, now we will be diving into another subtopic, which is called now the chemical families, and that's where now we will be able to be looking at one group at a time, and the characteristics that that makes them to be in the same group, that makes those atoms to be in the same group. Thank you. Remember to subscribe and share. Teacher Francis Omai, God bless you.